Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 46. The name of the problem is permutations. So given an array nums of distinct integers, return all the possible permutations. So you can return the answer in any order. So for a given number like 1, 2 and 3, there could be several permutations that possible, right? 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1 and so on, right? And we need to collect them as a list of integers, right? So we'll end up having multiple lists, and that's why we need to return a list of integers over here, right? So the problem statement over here is pretty simple, so do give it a try in order to solve the problem, and then you can check out the solution over here. So let's move over to the board and check out the solution. So I have taken the same example over here from the Leetcode problem, and we are going to see and understand visually how we are going to use recursion and backtracking in order to come up with the solution, right? So what do we know so far is every permutation that we'll create will have definitely three numbers, right? So let's try to build a tree based on that. So initially when I have nothing, what I can say is that I can choose between three of the values, right? I have an empty three placeholders over here, and our choice in hand is 1, 2 and 3. So we will always start from the left, and we will try to place a 1 over here, and then we go deep down into the recursion. So let's take 1 and then let's go to the next level of the recursion. So on the next level of recursion, what I know is that a place has been filled up on the previous level, that is at the level 0. Let's say this was my level 0, right? And this is my level 1. So at level 0, I always fill up the first element, then on the next level, I fill up the next element and so on. So 1 is already taken. So what is the choice for my second placeholder? So I have only to make choice between 2 and 3. And whatever can't be changed, I have just depicted over here with the red color. That means that element is fixed, right? So we choose a 2 over here, and then we go again into the recursion. So on the next level, we have two elements in red color, and we have only one choice. So we have to take it. So because we start from the left and we take a 3 and we are done. So when we come to the level 2, or when our level reaches the length of the input array minus 1, because we are doing of 0, otherwise if it is 1 2 3, then it would have been level equals to the size of the array. So whatever way it is, so when we reach here, we know that we have got one of the answers, so we store them somewhere in for the result, for our final result. So there is no way to proceed further. So we come over here and we check that are we on the last element of the array. We see that we are not, so we have some choices left over here, right? So once again, at this level, 1 is fixed over here. We cannot change 1 because it was set by the previous level, right? So I have a choice to make from 2 to 3. So now we know that 2 has been done. The only choice for me to make is a 3. So I go over here and choose 3, right? And I put the 3 and I pass on to the next level of the recursion. So in this case, 1 and 3 has been fixed, and 2 has been the only unused item. So I have left with only one choice, that is to put a 2 over here. So as soon as I put 2, and what I check is my level has reached the intended level. So I choose 1, 3, 2 as my another answer, right? So, so when I come to the previous level, what I see is that there are no more elements for me, right? So what I do is I go back one level into the recursion, right? And what we see is that there are unused items. So 2 is an unused item over here. So now the 0th element for this array has been processed. We'll move on, we'll increment, and we move on to the next element in the array. So we pick up the 2 over here, and we place the 2 over here, and we go down into the recursion. So this time 2 has been fixed by the previous level. So my only choices remaining is a 1 and a 3, and we start always from the left, right? So the pointer is over here. So we choose a 1 in this level, and we go into the recursion. So in this level, 2 and 1 has been fixed. So only choice is 3 for me. So we put the 3 and we have nowhere to proceed. And since it is the level intended level for the result, so what I do, I add to my result 2, 1, 3. So again, back at this level, what I know that 1 and 3 was my option, and 1 has already been processed. So this time I'm going to take up 3. So I put the 3 and I move on to the next level of the recursion. So again, at this level, 2 and 3 has been fixed by my previous level, and only item remaining for me is a 1. So I choose the 1, and as I choose the 1, I see that I reached the level. So we add 2, 3, 1 to the result. So we go back to the above and see that there is no more index available to the array. We go back again and we see, yeah, we have an index available in this array. So previously 2 has been used up. So this time I'm going to use up 3, the next increment to the next index. So I move on to 3 and I go into the recursion again. So this time 3 has been taken up. So my available options are 1 and 2. So we choose the 1 and put the 1 and go into the recursion. So at this level, my only option is a 2. We start from the 2 and we put the 2. And as we put the 2, we see that we have reached the level that is of the size of the array. So what we do is we dump the result into our result. So 312 is my another result. So now where to go? I go up and I see that there is one more element that we can process over here. So we fork another branch of the recursion over here. So one has been chosen earlier. The only choice that I have is this 2 over here. So we are going to take this 2 and place it into our placeholder over here and go down into the recursion again. At this level, we have only one choice to make from, and we make the choice 1. So we get our result since we are at the level. So we take the result 3, 2, and a 1. And we go up. We see we can't proceed here as well. We go up. We see that we cannot proceed here as well. So what will happen eventually is this will become my recursion tree over here. So this is the function that spawned everything, right? So this becomes my entire recursion tree over here, and here we have collected the result at every point, right? And this result is nothing but, if you see, this is the same result that we have got over here. These are the 6 elements that we got as a part of our result that we are going to process and send it back, right? So we are going to move over to the Leetcode and check out the solution quickly. So at first, what we are going to do is we need to return this list over here. So let's create this list, and this is what we are going to return at the end as well. So what we are going to do is we are going to create the function that we have mentioned over here, though we haven't named the function, but here we'll give a name, and we are going to create the function. We are going to see what all we need in that function in order to process things, right? So let that function be a void function, because I will take the list and I will populate the list. So of course I need the nums array wherein we have the numbers, the actual numbers. And also what we need to do is, right over here, what we did is we said that this has been used, this has not been used, right? We have been talking about it, but how do we get it programmatically? So we'll take a Boolean array and we'll call that array as used array or not. And this array is going to be the size of the actual nums array that we have received, right? And also we'll take a position. So this position is going to tell us where we are in the array. When we start filling up the array, which position we are in the array, and we'll soon see how this is going to help us, right? And also one thing that you have seen that so far we have been collecting these numbers at different stages, right? Before we put it into the actual result. So let's have an intermittent array over here wherein we call this collection array, where we collect the elements and we put the elements into its particular position, and at the end what we are going to do is we are going to store them into the actual result that we have created over here. So let's get that as a parameter over here as well. It can be optimized. I am not a big fan of having so many parameters to a function. 5 is actually too high, though we can optimize it. I'll leave the optimization part up to you, but let's keep it like this one now. So here we are going to call permutation, right? And we are going to pass in the nums array, and we are going to create a Boolean array of the same size as the nums array. So nums.length we'll use. And also, if you see this collect array, so how many elements it will have at the end when we collect it, it will have the same number of elements as the nums array, right? So we are going to create an empty array over here, which is also of the size nums.length, and the position is initially 0 because we are always starting from the leftmost index and we are going on, right? And yeah, of course we need to pass the result, wherein we'll be collecting the result, right? So this position is going to tell me that we have reached the end. So if you remember, we had this collection point, right? So this collection point, so this is indicated in our program by this variable called pos, right? So if we see that we have reached the pos has reached the nums.length, that means we have reached the end of the array and we are now ready to add the answer to our result. So we are going to do this part a little later because I don't want to confuse you at this moment. So let's first understand the core logic of what we are going to do, and then we'll see how we are going to get this done. If you remember, we have choices at every level, right? And what we did basically in all the cases, we iterated over the choices, right? So here also we are going to do the same thing. So we will be starting from the leftmost index and we will go up till the nums.length. So we are going to iterate over the choices that we have, and our used is going to tell me whether this number is available to be consumed or not, right? So at any given index, what I'm going to do is I am going to first check that if it is not used. So basically, let me put a not over here. It's not used, and we are going to check for the index. Oh my god, I missed. then only we are going to take this number. If it is true, that means this number has been used by some other level in the recursion, right? So what we are going to do is basically we are filling up for this pos, right? This position pos, right? So in the collect pos, what we are going to do is we are going to put this element. So we have found an unused element while coming from the left, so and we are going to put this element over here. Right, and before, so I have consumed one number and I'm going to push the rest of the numbers to the next level of the recursion. But before doing so, what I should do is I have to change my use die and set it to true. That means I am marking this index as used, means I have consumed it. Here I have consumed it and I'm just marking it. I have consumed it. Now you take the remaining. So what I'll do is I will call the permutation method once again with nums and used. So I'm not going to change them. I'm going to pass collect and we are going to put pos plus 1 over here, right? And result remains the same. There is no change to the result. So I'm going to pass it to the next level of the recursion. And once this recursion has ended, right over here, if you remember, once we have used once we have used one right over here, and when we are done with the recursion over here, and when we tried with two, we have set one to free, right? So there is a release associated with everything, right? Over here we have consumed one, but when we consumed three at the same level, we have set one to free so that the next level can consume it, right? So here in the recursion also we need to do the same thing. So what we are going to do once we are back from the recursion, so we are going to say that okay, used I is done. I have done the permutation for this I over here. I am going to now go to the next index. So before going to the next index, what I will do is I will set this number to false, so that at this level I have consumed one and checked everything. So now I'm going to consume two and check everything, but I should make one free so that the next level of recursion could have them. So that's what I did over here, right? So this is the entire logic over here. And what we are going to do over here quickly is, now we know that the POS has reached the level wherein now it should add the collect back to the result. But collect is an integer array and the result will have list of integers. So we have to get them converted. So we'll create a temporary result array and we are going to dump the temporary result array back to the result. So over here we have created a temp result array and we are going to dump everything that's inside this collect. So we are going to do something like this, and what we'll do is we'll add into the temp result, and at the end, once our result is populated, temp result is populated, we are going to add it back to the main result. Okay. You can use any library to get it done also, so I'm just using directly. So let's run this code and check how it goes. Yep, it's been accepted, and it took 0 millisecond for this case. So let's do a submit and check for a broader range of test cases over here. So yeah, we have a result which is 0 millisecond faster than 100%, though we have some memory usage, but still we are better than 83% of the submission. But that's not the point over here. What I want you to understand is how this recursion tree is going to be, how we are going to get into the recursion, and how things are going to come into shape, come into life over here, right? And also to understand the complexity over here, that is something pretty interesting, right? So if you see over here, so for three elements, if you see, your tree would look something like this. So the first level will have three, the second level will have two for each of those three nodes, and then for the third level you have one for each one of those nodes, right? So if I extend this, so when we have a four elements, so when we have 1 2 3 4, right, we will have a tree which looks something like this, which will have a lot of nodes, right? So we have four choices to make from. So we choose one and we are left with three choices, 2 3 4. We choose two, we are left with two choices, 3 4, right? So you can see here that the more the tree goes deeper, what we are going to have is more number of nodes, right? Only for 4 you can see that how it's changing, right? So with every level it will change, right? What is this kind of complexity called, right? How do we define such a complexity? How, like order of n squared, n log n. How do we define this? This is actually defined as an n factorial for your complexity, right? So you wanted to see how it goes. So this will have a 3 factorial, right? So 3 factorial, what does that mean? 3 into 2 into 1, that is 6, right? So you can see that we have 6 nodes over here, right? It's a factorial way it increases. So it has a 4 factorial, right? So that basically means is 4 into 3 into 2 into 1, right? which sums up to 4 into 3, 12, 24, right? So if you see here, we have 1, 2, 3, 4, 5, 6, 6 nodes for each of the sub branches. We have 4 sub branches, right? So we'll have 24 in the worst case, right? So this is the complexity over here. It's a different kind of complexity, I can understand. So it will be n factorial complexity, time complexity, wherein we are going n level into the recursion, right? Because as you remember that we get our answers at nth level, and at each level what happens is our choices decreases. At first, if it is having 5 numbers, right, 1 2 3 4 5, so I can choose from 5, so that will spawn 4 branches, right? So I'll choose another one and left with 3, it spawns 3 branches. I choose 1 and left with 2, I spawn another 2 branches. I choose 1 and spawn another branches, right? That's how we get this factorial number over here, right? So to understand in little more details, let's say we have an array of size 5, and we need to come up with this. And how do we get this 5 factorial over here, right? So initially I have 5 elements to choose from. Then I have 4 elements to choose from. Then I have 3 elements to choose from. Then I have 2 elements to choose from. Then I have 1 element to choose from, where I reach the level n, right? So under 2 I have 1 element to choose from, right? Under 3 I have 2 elements to choose from, means I can have 2 permutation breaking out at this point, right? So under 4, I'll have 3 threes to choose from, right? If there are 3 numbers, I can choose from, there will be 3 permutations call over here, right? Under this 5, there will be 4 fours similarly, right? So what it becomes, at this level, we have 4 elements, we have 3 elements, we have 2 elements, we have 1 element, right? So what will happen is basically 5 into 4 into 3 into 2 into 1. Then what I'll get is nothing but 5 factorial, which is nothing but this, which can be translated to say n factorial. So n is the size of our array over here, right? So this is just a little details for you to understand why it happens so, right? So at every level, we spawns out that many number of functions. So if you have a tree of size 5, what you'll see is that you have 5 factorial nodes at the end. Similarly for 4, we saw that we have 4 factorial nodes over here. We had 24 nodes over here, right? So yeah, this is the complexity all about. So do let me know what you think about this video. Do share your thoughts on the video. If you have any doubts or questions, do let me know. I will try to address them as soon as possible. If you're a first time viewer, do like, subscribe for instant notification of the videos. I try to create videos every single day or every alternate days. You can request a particular topic or videos. I will try to create videos on the same. I try to go as details as possible. I try to explain with as much visuals as possible, so that you can have a very clear understanding of how things are going, how we are dealing with different edge cases and all. So yeah, that's all from this video. Do take care, stay home, stay safe, stay healthy, take care of your family members. Don't go out, please. It's a request to all of you guys. Take care, and hope to see you guys soon. Bye bye.